Hello everyone, welcome to Seed Weekly live stream. This is Allison from Seed Community Team. So our topic today is about TinyML, shell, and AI applications across Asia, Europe, and Africa. We are very glad that today we are invited three very fantastic rangers from our community who will share their insights and experience. Moreover, today we prepared 2 rounds of giveaways, so hope you will get lucky. And before we are sharing today, so I'd love to give an introduction about shell. So some of people may never heard shell before. Shell is a very tiny and powerful microcontroller. So it is very suitable that people who want to make projects that very powerful and wireless connectivity. So it's also very compatible with Seed no-code model training and deployment platform SenseCraft AI. And it's very TinyML scalable. And we are so happy to share that our shell was featured on Science. Yeah, ta-da, it's Science. So we are very glad that we have this chance. We cannot do it without our community members' contribution. We also want to highlight that for this kind of blog, it also driving innovation in global south. So it has powering solutions such as detecting plant disease, monitoring pollutions, and improving healthcare with low cost and low power AI. So for the highlighted shell is for this kind of version.
Hendra, are you hearing anything? Any audio issues?
As
I think
for
YouTube sound is still active from Allison.
Okay.
I was opening the YouTube from my phone.
so for shell ESP32 at SenseCraft. So we are very proud to support TinyML 4D and the academic network in making AI more accessible and more impactful overall. So you can check out our blog at the chat box to know more exclusive discounts and academic support for our researchers and for the innovators. Of course, this would not be happen with our fantastic rangers. So for the rangers who are very passionate and eager to share their knowledge with us, so especially in open source hardwares and technology. So we will provide the materials, we'll provide the training for the rangers, and they will helping us to co-build the local community together. And very glad that we have more than 13 rangers globally. So we did a very great contributions. So today, we are very glad to invite Salman, Hendra, and Loic, who will share their experience based on like TinyML or AI and some applications they did in the previous like workshops, hackathon, and meetups. So let's get into our session. Our first speaker will be Salman Firas, who is the computer science graduate and very passionate innovator and interested with open source hardwares. So Salman has been spreading like TinyML, AI, and open source hardware across like India, UAE, and Vietnam, even in Shenzhen, China. So we, since like maybe 10 or 8 years ago, to collaborated very tightly. So let's welcome Salman to give his sharing. Hi, Salman. Hi, Salman. Can you hear me? Hi, Salman.
Salman, your microphone is muted.
Okay, sorry. Hi, Alison. Thanks for the introduction. I'm sharing my screen at the moment. Are you able to see anything right now?
No,
Is it visible? All good?
no. You're sharing your screen.
Okay.
Oh, yeah,
Can you
yes.
see the slides?
Yeah,
No, it's a black screen, right?
yeah.
Oh, okay. Just a moment. I think maybe in it.
Yeah, it's visible now.
The Seeed Studio live stream. I think the screen is changed, Alison.
The screen changed. Could you share your screen again?
Uh,
Oh, maybe the internet is a little bit unstable. So let's try again. Eh,
what about now? Are you able to see this PPT?
Not visible. It's still black.
It's black. Okay. Okay, that's very strange actually because I was able to see everything from my side. Okay. Let me do again one more time, please.
Yeah, visible now.
It is visible, right?
Yeah, visible now.
I think, yep, but the window is
Maybe,
automatically closed
sure.
in the live stream somehow. Okay, cool, perfect. Okay, yeah. Okay, cool. So it's all good. So it happens in the live, right? So hi everyone, my name is Salman. Today I would like to talk about what we did in the past as a ranger to empower the community by doing TinyML workshops. Okay. So yeah, welcome. So first of all, introduction. In Kerala, India. I work as a customer success at Screenly. I'm a co-founder of Makergram, a maker community based in India, and I'm currently as part of Ranger at Seeed Studio. It's been a long time. I've been working with the Seeed Studio, and I'm very happy and I'm very grateful to work with these amazing people. So I think Alison already mentioned about the Seed Ranger program. So basically, a Seed Ranger is a person who is a passionate makers who want to provide expertise, create collaborative things to the community, and lead innovation and in tech development. So basically, we are the people who passionate about things, and we also want to contribute to the community. So you can see the map, like all over the world, we are different kind of rangers. So it's a huge network, and it's full of amazing people. Okay. You can also apply, like Alison will share the link later. It's a field of study that's a combination of machine learning and embedded systems. So basically, we put machine learning on tiny microcontrollers. That's how small, low powered, and secure, low latency, low power devices. So it's basically we are running machine learning inference on edge computers or edge devices or tiny machines. So the TinyML workshop is like TinyML is amazing. Like I like TinyML is very much because it's a it's have a lot of real world applications. You know, we call like it's a new cool kid in the maker world, because before we have the hype on IoT, everyone is doing IoT. Now everyone is into the TinyML, everyone is doing the TinyML stuff, etc. But the thing is like not many people don't have the hardware or the knowledge to do the TinyML. So there's a gap. Okay, there's a thing. The industry is moving with the TinyML, but there's a people actually who don't have the hardware or the knowledge to the applications, because it's a combination of machine learning and embedded systems. Both are big elephant, right? Machine learning is a big subject, and also like TinyML is another, embedded system is another big subject. So to understand both of these is very difficult. So that's why that's where actually XIAO comes. XIAO is a low cost electronics development platform similar to Arduino, and we have tools like Gimbal, SenseCraft, etc. So these tools actually empower us to build machine learning on microcontrollers very easily. So in the past, it was very difficult. Like if you want to create a TinyML application or ML application, you need to understand a lot of complex mathematical things actually behind the machine learning thing, or you need to understand about more about the electronics, etc. But right now you have the tools, low-cost tools, and tools like Gimbal, SenseCraft. You can actually in 10 or 20 minutes, you can actually make a TinyML application. So the TinyML workshop is a one-day workshop with the focus of learning and building TinyML projects. So at the end of the workshop, every participant should build their own TinyML project. It's a must. And the workshop we did, most of the people able to do that. So that's a good thing. So the hardware we choose, like one is XIAO ESP30 to S3 Sense and XIAO NR50 to 840 Sense. I love these two hardware. One because like the ESP30 to S3 Sense have onboard camera and onboard microphone. So it's very good for computer vision application or speech detection based application, etc. And the NR50 to 840 have accelerometer and gyroscope. So that means like you can do like gesture based application, etc. So these two hardware I mostly use for doing the workshops. So, and I love those XIAO devices. So yeah, I took my first workshop at the Fab 23 conference in Bhutan. It's like a yearly Fab Academy and Fab community gathering. And thanks to Blues.io and C team, Eric, Violet, and Allison to believe in me, to help me to take the workshop in a big conference, you know. And it's went successful. We have around 25 people actually. We took two workshop in a Fab 23 conference. One we did, then after we got many requests, then we took another workshop in second day, and it's both are successful, and like people I actually enjoyed doing TinyML. So after the workshop, what I did, like I contributed to the Seed wiki and create a curriculum, like how other people or other rangers can do the similar workshop in their community. And I also created another like a page called workshop.makergram. Like we documented fundamentals of TinyML, fundamentals of Arduino, because I understand like people actually joining our workshop is sometimes like they don't have any experience with Arduino, they don't have any experience with electronics, etc. So it's a must that we need to put fundamentals things or basics in a single space. So we created the workshop named Makergram, and along with that, Seed Wiki is a wonderful resource. We document all workshop curriculum. So yeah, I started contributing to that after the first workshop. Then after that, I took workshop like 10 plus colleges and locations in India and 4 plus universities in UAE and 4 days innovation camp with the TinyML in 2 times with the support of like UAE government, Hamdan Foundation. And we took a TinyML workshop at Force Asia Summit 2024 in Vietnam. That's very interesting and like amazing stuff because most of the things like Force Asia or any other tech conference most focused on software workshop or software training, and we are the only one who actually took the hardware workshop, and it's a great experience for us and the participants also. And then I also got an opportunity to do a TinyML workshop at Shenzhen Maker Fair. It's one of the best maker fair in the world. So it's amazing. Okay, so about the stats. So total around the workshop actually benefited 500 plus participants across everyone, including the universities, including the like for say some summit, 10 plus college, etc. It's around 5 plus participants, and you can see at the end of all the workshop, the student is able to build their own application. Like they collect their data set, they train the model, and they deploy the model on the Xiao. And like it's very like happy to see the joy in their face once they build their own project, and they're like, yeah, I made. Because like when we start the workshop, they actually feel very sad, like, oh, we don't sure we can complete the workshop. Then I mentioned, okay, trust me, like you can able to complete, because it's not due to the tools we use, it actually make them enable like TinyML application very quickly. Then another one of the interesting workshop I like, the Faber workshop. It's with collaboration of Kerala Startup Mission and Fab Lab Kerala, and we took a TinyML workshop exclusively for women. And thanks to the volunteers like Zain, Fasna, and Fab Lab team to help me along with the workshop. It's also amazing. Like the thing about this workshop is not limited to the students. In the Faber workshop, we have people who actually doing the PhD. We have people who are actually working in startup ecosystem. They have like clients that's work with the computer vision, etc. And we have students like regular students. We have like school students, etc. And yeah, at the end of the day, like they learn about the TinyML. They build their own application. And like this is another achievement we did with collaboration of Hamdan Foundation and Fab Lab UAE. We took a 4 days innovation camp. It's a big thing because like normally we did 1 day TinyML workshop, but this one is 4 days innovation camp. Like first day they come and they will understand about the fundamentals of electronics, etc. And second day actually they understand about the problem around their community in UAE. And the third and fourth day, we try to ideate, make their own application. So let me play the video and you can see how it works in the action. Yeah, like it's actually a like a very interesting group of people. Like at the end of the workshop, actually, I too amazed about their dedication on completing the project. You can see almost all the teams. They built a complete end-to-end product, like a project. Like it's not like a simple DIY project. They made their like they use the Fab Lab, they use the 3D print, they use like all the detail fabrication tools. Like this project actually I like this is a baby monitoring system. So one of the team member friend actually had a have a like a newborn baby, and she has actually have an issues like whenever she meet her like a friend, she's very conscious about her kid. Like she regularly check and see if the baby is awake or not, if it's crying or not, etc. So what they made is like they made a like a baby monitor system to recognize the baby crying, and they get a notification if the baby is crying in Telegram. So they made completely from scratch. Like they use the XIAO ESP32S3 Sense to capture the voice. Then like they don't harm any babies. Okay, so they just collected the voice from internet, like the YouTube, and collected the audio. Then they train using 8 gimbals. Then deployed the model on the XIAO ESP32S3 Sense, and they actually bought a baby doll, and they made a baby they brought a baby doll, and they made a like, beautiful acrylic cradle to include the baby. It's so amazing actually see. And another team is actually they made a accident collision detection device. So basically there will be in UAE there are so many remote areas. So when there is a accident is happen, it's like it's very likely not likely to like let know the authorities. Like so they made a system where it can attach the vehicles, and it's actually NR50 to 840 cents utilizing its accelerometer and gyroscope. If the car is to collide, they will if it's an accident, the authorities will get a notification from their location. So it's actually a wonderful project. And another team is actually they made actually a wristband for elderly people. So when elder people is like fall from while walking, the authorities like or the daughters or son, they will get a notification. Hey, your parent is like fell. Please keep a look at it, etc. And another team is actually made a project with the sign language monitor, where they actually use Xiaomi SP30S3 Sense camera to capture the signs and inference with like LEDs and micro speaker. So yeah. So that's about the TinyML workshop, and I don't have time to display all the workshop we did. I actually want to share all the workshop because each workshop has a lot of learning, lot of stories, a lot of amazing things to share with you. But we have limited time. So what are the things I learned from these workshops? One important thing is you will learn more if you share more. Like I know like I know something, but when the moment I share with the same thing with others, like they will ask more question. More questions means the questions or the things that I don't even think about. So I'll search for that and I learn more about that. Sometimes me and the participants, the students together, we found some solutions, because we don't know everything, right? We know something but we don't know everything. So sharing is the one of the best way to learn more. So that's why I like to share. That's why I like to host workshops, etc. Another thing is sharing is caring, and it will help other people. After that completing the workshop, we can see the confidence in their eyes. Like they can build something with electronics, they can build something with the TinyML. Because when starting the workshop, most of the people actually we can see from their eyes like they sharing like, oh, we don't know anything, etc. But after the workshop they have some confidence, they have some level of confidence. Okay, these can be also done by me. I can go and Google or search. I can also build something. And I know many people actually after the workshop, they did so amazing contribution to the community by doing more workshop and doing blog post, doing project, etc. So I am so happy to see that they also share with me also. So it's a different level of feeling. And I want to share a big thanks to Seed Studio and its people. Like they supported. Without them, actually, it can be happen because with their Xiaowo, it's not all, no, it's not about giving hardware. It's about like believing us, like as a ranger, believing us. They actually fully supported. Whenever I message Alison, hey Alison, I want to do a workshop. Alison, yeah, go ahead, take the workshop, no problem, etc. Eric, the Seed Studio CEO, and my friends like Lily, Violet, they all actually very much support doing these things. So I am very happy and very proud to be as a ranger. And like, if you also like passionate about these kind of stuffs, please apply for ranger. You can also meet amazing people. Like the next speaker actually also Hendra and Loic is also amazing rangers. So yeah, thanks for your time, and thanks to Seed Studio, and thanks Alison for letting me share these TinyML workshop series with everyone. Thank you. If you have
Thank
any
you.
question, please do share it on the comments, and I'll share the links on the YouTube comment later. Okay, thank you.
Okay, thank you, Salman. Thanks for Salman's sharing. Yeah, so I noticed that some people asking the chat box that to see if we have the online workshop. Yes, we did. But if you want more like events happening in your area, you could go to our like ranger landing page. You could check which like who is the nearest of you, and you can contact with him or contact with her, and to make more events and more possibilities happen. Yeah. Okay, then let's doing an exciting part. It's our giveaway. So for this round one giveaway, we will send out one SenseCraft watcher. So the rule is who answer the question correctly in the first time in the chat box will get it. So are you ready? Our question is, which version of shell was featured on Science? Like, have you mentioned that? The tips is the one with the camera one. So let's see who got lucky today. I already saw the winner, same tag. So my colleague Ray will ping you around the chat box, and then you can contact us to get the giveaway after the live stream. Thanks for participating. So next time, let's welcome our second ranger, Hendra. So Hendra is a lecturer and also the professor at the University Rajahar. He has been very actively bring AI, mesh testing, IoT into like his campus and also beyond Indonesia. So except for that, he provide his expertise into support with the FabLab Bali and also some non-profit organizations and enterprises. So let's hear what he gonna share with us today.
Okay, thank you, Alison, and hello, everyone. Thank you, Alison, also for the introduction. So let me share my page for the first time. Okay, so actually, most of my before I share about Xiao and a few things that I did with Xiao. I'll share about in a moment about my experience for becoming a legend for the past year. So all my action, all my things that I did for the workshop is mostly based on Salman's material. So thank you, Salman, for that, for making easier for us to share the TinyML knowledge to everyone here. So this is a recap of my past workshop. In all of it is in Indonesia. I did a workshop in Bali. I do a workshop in Yogyakarta. I also do a workshop in Jakarta as well, in the capital city for obvious reasons, because I live near Jakarta. And the participants, it's not much different from Salman. Most of them don't know about TinyML, and most of them also don't know about coding as well. So it's quite a challenge at the first time because can I share about technicality of machine learning to the people who doesn't even have interest or maybe doesn't even know how machine learning works. So the shell ESP32X3 Sense is becoming the bridge of that knowledge. It's easier for them to understand, oh, so that's how machine learning works. So they don't need to understand the complex stuff here. They don't need to understand the PyTorch, the TensorFlow, the NumPy part of the machine learning. No, they don't have to, because with a shell and one platform from the Seeed Studio, one software, which is SenseCraft, make it easier for them to understand. So one of the most impressive workshop that I did for last year is when I do a workshop for biologists. So all of them are biologists. They don't have any knowledge coding. They don't have any knowledge about machine learning. So I get there with the help of a professor from Malaysia, Pak Nick, invited me to join the program in there. And yeah, so this is the situation in the workshop where most of the participants doesn't know about coding. Doesn't know about coding, and I teach them about, and they get a few ideas. Oh, so I maybe I count how many bees that I observe and push it into a data. Yeah, that can do it as well. A few people also already take interest implementing ESP32 Sense through their research. And one of the recent workshops I did is one of the features is the SenseCraft AI now have SenseCraft AI now have a training part. And make it easier for everyone to their own custom model. So this time I do a workshop February last month. I do a workshop at this company, and one of the participants doesn't even know how to hold the computer. Maybe he is rarely using a computer. Most of the time, he's using only a smartphone. So again, it's a bit quite of a challenge for me to share about AI to that person. But in the end, he managed to make his own custom data model with the help of the SenseCraft AI. So this platform is impressive. I have a video here, but if you want to check the full blog, you can check the Seeed Studio blog. All the rangers are recapping their activity in there. So if you want to check all the videos and all the testimonial of the excitement of the workshop, you can check on our blog post. So yeah, that's a bit of my experience as a ranger, and mostly what I use is ESP32 XIAO ESP32 S3 Sense microcontroller. This small guy. Okay, so now I want to share you about. Okay, let me try to change. I will share to you about the. Okay, my screen is not. Let me change the screen first. Is it visible? So this is the SenseCraft AI. I don't think it's visible yet. Okay. Okay, so this is the SenseCraft AI where you can use the shell ESP32 Sense, and this platform heavily focus on the no-code execution or the no-code no-code application part. You can upload a custom data or data model, an existing data model that already provided by the platform. In here we how many? It's like 14 or 13, around 14 data model that you can try. There is a person detection, gender detection, person classification, etc. This time the shell is running the person detection data model, as you can see. This part, it's quite obvious. Now, what I want to share with you on how you can create, sorry, let me stop this first. On how you can create your own custom data model without any knowledge of the code. So this has been a quite fun experience recently for the participant of my workshop, because when they found out that they can make their own, they are pretty amazed and they have a few ideas what kind of application or maybe some kind of project they want to make. Okay, so we go to the training part. To do that, we make custom model. We go to the training part. Here, yes, I'm gonna leave. Okay, training part. Okay, let me try to turn off my webcam. I will teleport to the SenseCraft platform. Okay, not readable device. Okay, let me refresh this for a while. Okay.
Cool.
Now I am teleported to the SenseCraft platform. But you can use any webcam to collect. So what we are going to do now is collect a data set or taking a picture of an object that you want to train, that you want to make the data model of. To capture the object, we can use our computer webcam or our laptop webcam, or you can also use the shell itself. So here, there's an option to choose the shell ESP32 Sense. Yeah, let me try to use shell. But for now, I don't think I can use shell because it will take quite some time to capture using shell. Okay. There's a difference in the quality. Now, as you can see, you can also use the shell itself to capture the image. But for the sake of the accuracy, for now, I'm going to use my webcam. Okay. So I have two objects in here. I have board marker here, and I have a yo-yo. Okay, so I have two yo-yos actually. So I will try to make a classification data model, a custom one. Let's say this is one is a marker. Now we can take a picture of the marker. Actually, if you want to make a good data model, it will be better that the object doesn't have any background. So because I have a limited space on me right now, I cannot move the webcam. It will be throws it anywhere. I'll do my best to minimize the background, so it will be focused only just on the marker. I'm gonna disappear for a while. Just let the marker take the whole show. Take as much as you want. You can take 400 and take as many angles as you can. 100, 200, 400. Okay. Okay, 50. 50 is good. Okay, now for the second object. Yo-yo. Okay, yeah, same thing. I'm not going to be in the frame. Let yo-yo be the focus of this object. Make sure to get all the angles covered. The greater the better. Okay, and now we add one class, which is the background class. So if there's nothing in between those two objects, it will be read as this third class. So we can call it a background or an empty class, anything you want. And you can fill it with any kind of image beside those two, beside the marker and beside the yo-yos. So this time I'm going to take my own picture from any kind of angles, also a hollow. So it doesn't detect a marker or a yo-yo. It will be read as a background only. Okay, I think that's enough. Okay, now we are going to start training the model using the dataset that we already captured before. Make sure you choose the Xiao ESP32S3 Sense. I promise you this is going to be less than 10 minutes, hopefully. Now start training. After this, the SenseCraft will make the custom data model on the server. And let me explain to you, let me share to you that this is one of the fastest data model creation, because sometimes when I want to make my own custom data model on my own PC, it took like 20 minutes, 30 minutes, but with the same amount of data, with the same amount, also with the same concept, which is classification. But SenseCraft only took like 3 or 5 minutes. 5 minutes is the longest, and then you're done and you're good to go, which is awesome. Okay, it's still 40%. Don't mind if you want to do this in your own hardware, you can. You also can. But there are a lot of steps that you need to do. There are a lot of software that you need to install, and also there are a few knowledge that you need to understand. Okay. Now the model is ready, but this model only still run on the server, which can test it out if it's working or not. As you can see, now it's read as a background. Now it's read as a background, mostly. Now, if I put my marker here, as you can see, it's 90% classified as a marker. No matter how you position the marker, horizontally, vertically, it will read most of the time as a marker. Now we change to the yo-yos. Yes, yo-yo. Okay, same as before. It's quite accurate at the moment, but still, this is still running on the server, not running on the shell. So what should I do if I want to run this on the shell? Usually, I need to download the data model and I need to open it in Arduino, and I need to do a lot of coding stuff. But in the SenseCraft, you just need to click this button and then you're good to go. This is awesome. Okay, so just click this button and then you will be directed to the previous page. Confirm, I want to deploy this model to the shell. Okay, connecting. Now we wait. The flashing part also is not that long. Don't mind, this is classification, not detection. It's a bit different. Okay. I have to make sure that I put the shell camera on the same position as the webcam. So avoid any kind of confusion. Okay, so if I put the marker now, is it ready marker? As you can see, when marker enter the frame, it read mostly 90% as the marker. Okay, now the yo-yos. The yo-yos. Now you see, the yo-yos are read 90%. This is a quite good data model. But do mind there are also some aspects for the data set. The lighting condition is also a great factor for it to become a good model. And also there are a lot of factors as well if you want to make your own good custom data model. Okay, pretty exciting. So if you have your own XIAO ESP32S3 Sense after this session, maybe just grab and then try this awesome feature from SenseCraft. Try to maybe detect your own pets, your maybe a chair or any kind of object that you can try. Okay, so next part that I want to share. Okay, let me stop sharing first and turn on the camera. And I'm back to the Zoom. Okay, before I do this demo, I want to show you what I did. Okay, so I make this contraption.
Hi, Hendra. Could you share your
My picture is
camera?
gone in the stream somehow, but it's okay. I made this modified growth.
Hi, Hendra.
Modified growth.
I couldn't see
so
your
one XIAO,
demo.
one XIAO, the ESP32S3 Sense. Wait, let me try to. Oh, the picture is gone. Okay. Okay, let me do go to the part of the code.
Hi,
Okay.
Hendra. Oh, okay. Yes.
Okay. I'm going to the part of the coding part. Okay. So what I'm going to do is the XIAO ESP32S3 Sense is already running the data. So this one XIAO is running a face detection data model. But this is the fun part. I want to send the detection data. So if there is a face detected, I want to send a notification or send a message to the mesh static network. As you know, we also past few weeks or last week or past few live stream, since we already covered about mesh static. So I want to try to combine this both of two worlds. So this code is on the wiki. If you don't have code, this code, all the code is on the wiki of the Seeed Studio. It's a pretty simple, straightforward code. Here on the code, what I modified on the code is when there is something detected, we get instant boxes here, and we send a serial data with the sentence, and then we send the confidence score on to the message file. So this serial is actually sending data to a metastatic node that receiving the data serially. So actually, this is two XIAO. One XIAO is running metastatic. One XIAO is running the TinyML. Both are connected via the UART line. So let me plug this out. Okay. You can see in the bottom the serial monitor. Okay, we said inferencing in the bottom. Let me pull this one. Now, if it's directed to my face, it will be some kind of data reading in the serial monitor. Wait. Okay. camera is blank, like black. Okay, let me try to stop sharing. Okay, can you see me now?
No, still blank. Still like black. So maybe like
Okay, let me
try
try one more
again.
time. Is my camera okay now?
No.
Still no camera. Okay, let's not focus on the camera because and then I'm going to share the page. What's my recent page?
Okay.
So now we are going to the Mestastic client. So I already have Mestastic client running in here. Yeah, where is my Mestastic client? Okay, so this one. Is it still black, Alison? Oh yeah.
Could not see your camera.
Okay,
but
can you see the Mestastic client page now?
But the page is okay.
Okay. Now, you see this one is a Mestastic client, web-based Mestastic client. So I have another node, another shell with the shell with the LoRa Mestastic module connected to the computer, and this is the node. And the other node is connected physically to the shell with the TinyML data model. So every time I try to, now I'm going to try to do a face detection with this shell. Sadly, my camera is blank in there, but the camera here is doing well. So if there's any face detected, it will send a message directly to the primary channel of the Mestastic network. Yeah, let me try this one time. Okay, let me refresh this. Okay, 0.75. Try again. So this is basically all the notification that is I tested before. So every time I put my face, as you can see, there's a new data in there. That's not me who typed the data. Still, the text is still a bit of a mess, but it can be made more neatly later. But as you can see, the detection part is working, and then when a face is detected, the shell ESP32 sends with TinyML will send data via UART to the shell with the Mestastic, and the shell with the Mestastic will send the message to the Mestastic network around it. So this is the Mestastic network that you are seeing right now. We have two nodes active, which is the node that you are seeing right now, and one node is connected to the TinyML. So yeah, this is, you can modify this code. Okay, let's get back to the Arduino part. You can modify this code as you want to. Maybe you want to extract the reading only or how many object is detected. Just modify this code in the Arduino part. What I sent is only the confidence score. So if there's a face, send this text and also send the confidence score of the reading based on the TinyML. So do remember this TinyML, everything, every reading, every machine learning part is done by the shell, not by the computer. Yeah, including this one, including this demo. Okay, let me try one more time. Face part. Okay, face part is good. Okay, I think that's it for my part. You can do many kind of more stuff with the SenseCraft, with the show ESP32 S2 Sense. So finally, my face is showing up. Okay, so you can do many things. You can add more sensor, you can add more AI module, or maybe you can add Grow Fusion AI V2 to the Mestastic network. Anything you want. So thank you, Alison, for the session, and I am giving it back to you. Thanks everyone for watching the
Well,
session.
thanks, Hendra, for sharing for the very specific demonstration. So yeah, you can use SenseCraft AI, easily train your R model and use few seconds, like a minute, to train it and make your projects happen. So now let's doing a round 2 giveaway. So this time we also will send a SenseCap watcher, and the rule is the same as the first round. So the first one who answered the question correctly in the chat box will get it. Are you ready? This time our question is, what is the smallest size of shell? What is the smallest size of shell? Let's see who get the right answer. And we saw the winner, I think. Microslaw or Joki. So we will help to select the winner and pin it to the chat box, and you can contact with us after the live stream. Okay, let's welcome our last speaker, Loic. So Loic is the education ambassador in Cameroon. So recently he has studied in France and also bring lots of robotics like tech into France and Italy. Also, he brings like IoT and smart agriculture to the Cameroon. So let's welcome Loic for his sharing.
Hello everyone. I don't know. Just give me a second. Okay. Is it okay for everyone to see or hear whatever I'm saying? Hello?
Hello? Yeah. I can hear.
Yes. Okay. Okay. Okay, perfect. Let me just go to my presentation. Okay, I hope everyone can see my screen.
Yes.
Perfect. Good morning, everyone. I'm called Disafomikon Jeffrey. As Alison said before, so I'm also the team education ambassador in Cameroon and the ranger, a Seeed Studio Ranger in France and in Cameroon. So the main objective is to inspire, empower the local community with the new technologies such as TinyML, IoT, into various use cases in order to impact positively our community. So I'm doing a master research in radio communication. So I am mostly focalize on antenna sizing and how to operate in order to collect and transmit data at the very long distance using various technology as LoRaWAN, Wi-Fi, 5G network, etc. So today I'm going to present you the application of TinyML and IoT in smart farming. So this is one of our use case project that we perform during our Seeed Studio workshop session that we did last year, and the preparation of the next workshop that we are going to do at the University of Yaoundé and that of Douala for the nearest week coming up. So for this presentation, I will specifically emphasize on the problem because in order to make this project, we need to inspire and empower the different learners on how they can turn that technology into action and solve problems. So we need to identify a problem and how we can use now different tools in order to resolve the issue. So the problem that we identified in our region was mostly the impact of climate change that affects the farmer, particularly the farmer that practice irrigated agriculture. And due to the climate, it changed everything because people were depending on the climate in order to make the different culture. But during this time around, like in Cameroon, it was supposed to be the raining season, but it is instead very hot. So everything has changed. That is during this time we're supposed to cultivate more tomato, but it has changed due to climate. So now it is another form of culture that is being going on, and that is mostly corn. So with this in fact, with this problem, we decided to create a solution based on the different technology that I'm going to talk about. That is the TinyML and IoT. So I will mostly talk about the IoT, then go to the application of TinyML as a decision tool in our problem-solving solution. As you can see, the problem is selecting the profitable crop for selecting the profitable crop for a season and making decision in which suitable season or period is suitable for a planting and harvesting, and in fact for a planting and harvesting. And number two is selecting which suitable crop are compatible for the given soil in order to have a higher productivity yield, and also have a decentralized weather data and real-time prediction of the climate change to take good decision. So in order to do that, we're going to make use of Internet of Things and the use of TinyML. So in order to make the use of the Internet of Things, there are many tools that we are going to use that is being provided by Seeed Studio. And one of the best tools that we have used as a use case in our own community is the SenseCraft. So like you are saying, this is how the problems really occur. And these are the different technology aspects that we're going to talk about into the project, and how we are going to set up the huge network in order to collect the data, transmit the data, and also apply now machine learning in order to take a good decision from the prediction that we are going to have as a result. Okay. The solution that we directly propose for, and we have tested. Let me just redo this. Okay, perfect. Voilà. So the solution that we propose is based on LoRa. So we decided directly to create a very big network based on LoRaWAN. So the network consists of nodes that is made up of a farm bot, as you are seeing here, a weather station, and SenseCraft, and the different SenseCraft industrial sensor. So all these nodes are this node has for objective to collect decentralized data of the given environment, that is the given farm. So, and all those decentralized data are being collected directly and passed through a gateway, that is the gateway that is the interconnectivity between the local network and the public network, that is internet. So all those data are being transmitted over, and the data are mostly the temperature, soil moisture, NPK level, humidity, atmospheric pressure, wind direction, and the wind speed. So all those data are being transmitted to the gateway that are being registered to either the or SenseCraft. So this network is here just to make an interconnectivity between gateways in order to rely, in order to rely our data that is being passing from the local network to the public network, such that anywhere we are in the world, we can access to our data. That is in case that one of our gateway gets off, so the data is going to rely to another gateway. So this network is such a commutative network in order to maintain constant data transfer. Then at the end of the data transfer, we apply multiple protocol. The famous protocol that we mostly use is the MQTT. That is the protocol that helps us directly in order to capture our data and make sure that we can visualize our data through a dashboard that we use called Node-RED, that is open source. And Node-RED is a simple web interface that helps us to create dashboard without coding. So from Node-RED, you can easily create your own dashboard as we are seeing here without coding, such that you can visualize your data locally or anywhere you are. So to visualize the data anywhere you are, you need to use the protocol like MQTT, HTTPS, and various other protocols, but the famous one is MQTT. So at the end of the process of our solution, the main aim is to provide a decentralized data with an affordable and a perfect user interface directly to the farmer. So the interface appear as follow by showing directly a map with a different location in order to tell them that, okay, from this precise location, you can practice this type of culture from the data that we have collected from the LoRa nodes. And the culture could be the practice of granite, tomato, Irish potato that directly by giving all the sensor data values directly to the dashboard. And also at the end, in fact, at the end user place, there is a huge application of TinyML. So the huge application of TinyML in this is to make directly the 12-hour prediction, or even the one, in fact, the 12-hour prediction of what is going to happen about the climate. That is, it can predict the 12-hour rain forecasting, such that the farmer is aware and can readily take the best decision for his environment and for his farming practice. What is SenseCraft? So SenseCraft is a huge product that provides software cloud services API, allowing user to collect, store, analyze data in real time. It is also the vast combination of hardware and software cloud services that enable quickly respond to change in their environment and make their data-driven driven decision. As you can see, so SenseCraft provides many tools, many products that helps you to collect all those really rapid data that are very useful for your own IoT project. As you can see, we have various products that consist of climate climate weather sensors, industrial sensors, and different other. And we have also the famous dashboards from SenseCraft that helps you directly to that helps directly to display all your data being collected directly from your different nodes that you have installed in your environment, either in your house or either in the city. So it has various use case and application. So the network solution that we propose as I shown before. So this is a network that we choose directly in order to show how we can collect the data from our environment and transmit it directly through our LoRaWAN gateway, and we go directly to the different server platform. So we can use SenseCraft server, we can use the Things network, and we can use Helium. And at the end, when we receive the data now, we can now apply our machine learning algorithm in order to get the results and the prediction and take an action directly. So like I mentioned before, the different tools that we use in our project was number one, the SenseCraft weather station that we installed in order to collect and provide a decentralized data. We use the SenseCraft M2 Logger gateway. We use also the SenseCraft industrial sensor S2101 and S2103 in order to collect temperature, humidity, soil moisture, soil conductivity, and carbon dioxide. We also use a SenseCraft tracker in order to track our farm board that is embedded with the various sensors. So the main aim of our farm board is to move into the farming area and collect data and provide the data corresponding to the GPS location, such that we should know at which area we can practice a particular type of crop. Because at the end, the data that we receive correspond to the different area at which the farm bot has performed his own trajectory. And we also use the growth sensor XIAO RP 2040 that is embedded to the farm board, because we have other various sensors other various sensors like I mentioned before that is embedded on the robots, and also with the MPK, and also with the growth AI sensor. So the growth AI sensor is just to as soon as the robot is moving into the farm, the robot also takes the different image of the different area and also of the lift in order to tell us how the lift is directly, and also to compare with his own dashboards about the plant health also at real time. So the solution description is a TinyML algorithm that recover and deduce from the geospatial soil and weather data received from the robot of the farmer's activity plot according to the chemical component soil, that is the pH, the NPK, rainfall, temperature, moisture, that are all embedded on the robot, produce a list of best yield of different crops that can grow and the probability of production of each type of crop, and also how the crop can be optimized and adapted to the different climate region. The result that we obtain at the end of the process is a dashboard that shows us directly the probability of production of each type of crop that you can practice in the corresponding area. Like from the test that we did, we obtained a higher probability of production of coconut and rubber, and also cassava tuber. So, and we also obtain a 12 rain forecasting prediction notification from the dashboard. And directly after obtaining the different results, so we decided to make this of use case by inspiring the students from the University of Douala at NSET on how we can set up and install our LoRaWAN network. So this is the process of the installment that we did with the students in Cameroon. So in order to install the gateway, you need to make sure that the gateway has a very big area coverage for the data transmission. So the main aim of installing this gateway, firstly, is to allow the students with their various other projects in order to install and connect and also drive their data through our gateway that is open source. So in Cameroon, we have installed up to 2 gateways. So in Cameroon, we have 2 gateways that are installed and readily to use by the students with their own project that they want to perform. The second mission also that we did was in France. So the main aim was to directly track and collect data of an electric shuffle. So in order to establish this process, we needed to install a gateway at home and also to install a LoRa node directly that consists of our electric shuttle. And the main objective was to make sure that we know the maximum distance at which to receive signal. So the main aim was to collect the data through the journey of the electric shuffle from CAM to Wistriam. And the test that we obtained at the end with our antenna being installed was a 30-kilometer of data transmission. And in fact, the area was being covered perfectly, and that gave us directly the different possibility to move really and collect data with our electric shuffle. So the main objective of collection of data of the electric shuffle is to really send the weather data and the other sensors that are embedded in the electric shuffle, such as temperature, humidity, over LoRa. Okay, and the third mission that we did also is to empower the local community to collect weather data by building an entirely community-owned balloon and weather station network for the prediction of the 12-hour rain forecast. So the main objective was to launch a payload into space directly and to collect the different climate data and provide it direct to the community. And the most important thing was to directly predict what is going to happen in the nearest 12 hours. So I will just go directly to a simple demo of the workshop that we did directly with the students in the University of Yaoundé and in the University of Douala. Okay. So this is one of the different activities that we performed celebrating the first Seeed Studio IoT LoRaWAN workshop in Douala and Yaoundé. So this is how we perform the different activities. And the workshop content was to create our own LoRa node and transfer directly the data using the SenseCraft gateway. And the workshop was such a success. And the students were very happy to have learned something new about Internet of Things. You know, Internet of Things is something that is very new into our community, and people are not aware of IoT and also with the use of LoRa. And Internet of not only composed of LoRa, is mostly composed of many other type of network that you can use, either Wi-Fi, Bluetooth. So that is what we emphasize directly with the students and showing the different use cases. And the project that we did, so the main objective was to connect our nodes that is composed, I don't know if you can see, that is composed of DHT11 to collect temperature, humidity, soil, moisture, and also to transmit our data passing through our gateway, and have a widget dashboard that you can open directly anywhere you are using the MQTT call and visualize your data in real time. So as you can see, we have the temperature that's been showing in real time. You have the humidity and you have the soil moisture. And also you have the possibility to directly switch on and off LED. So this demo was just to show to students how we can connect our plant pot into internet and directly irrigate our plant pot and get the data in real time. So thank you very much.
Well,
Thank you very much. Okay, I would like to thank Alison, Lily, and Violet for the opportunity. And this opportunity is one of the greatest opportunities that we had in our own community, in such a way that we had the possibility to get different tools to perform different activities in our own community and bring out a tech solution with the different tools such as XIAO, SenseCraft, and various other tools in order to solve a different problem in our own community. So thank you very much for the.
thank you so much for sharing, Loic. Yeah, so for the above sharing, that we are very thanks for the Hendra, Salman, and Louis' contribution. Without their efforts,
Hello? Yes.
Yeah. Without their contribution, we cannot go to these steps connected with our community, this kind of closer. So if you are like passionate with tech or community co-building, welcome to sign as or apply as ranger, as Seed Ranger as well. So we are also eagerly to welcome everyone who are joining this family with us. And meanwhile, if you would love to make more events happen, you can connect to the local ranger, like the
Hello?
most nearest to you. Hi, Loic. The nearest ranger to you and make something happen. So that's all for the sharing today. If you have any questions, feel free to contact with us like via website or the social media. So we hope to see you until next time. Bye bye.